In this video, we'll talk about distance versus displacement. So let's say we have a coordinate system like this. So we have positive x to the right, positive y upwards, and so we have our origin right here. And let's say we have a particle that starts out at some point here. We'll give this coordinates maybe 2, 3. And then we could say it has a position vector. We'll denote the position vector with an R. And we'll say here position vector R1. And so position vector R1 would be how this particle moves, or how it's positioned from the origin. So this is has basically just the coordinates 2, 3. And then let's say then it moves over here to another point, and let's say this point is located at 5, 1. So 5, 1 here, and so then we have position vector R2 right here, and so then position vector R2 is equal to 5, 1. Then the displacement between these is defined to be just the change in position. So this is the displacement as it moves from R1 to R2. So this would be our displacement vector. And so the displacement is equal to the change in the position vector. So this is equal to position vector 2 minus position vector 1. And so then our displacement is going to be equal to, we have, this is 5, 1 minus 2, 3. And so we have our displacement vector is equal to 3, negative 2. So this is the displacement of the of this. We could talk about its components. Normally we would just give this like a delta x and a delta y. So we could talk about our displacement vector in terms of its components. So we could say the delta x here, the displacement in the x direction, that's what this delta x is, was 3. And the displacement in the y direction, delta y, was equal to negative 2 units, whatever. This is probably in meters or something like that. Our units of displacement are generally in meters, some length, meters, feet, miles, kilometers, etc. So displacement is actually a change in position. Then the magnitude of this displacement would then be, we could find this from Pythagorean theorem, it would just be the magnitude of this vector. And so then the magnitude of our displacement would be the square root of 3 squared plus negative 2 squared. And so this is equal to the square root of 13. Would have been the magnitude of this displacement. So displacement is a vector, and it is a change in position. Distance, however, is just how far something travels. So this was a straight line between these two. So it happens that the distance traveled was equal to the square root of 13. So that's what the length of this vector right here is. That would be the distance. But it's not always just the magnitude. The distance isn't always just the magnitude of the displacement, in case we have a negative displacement as well. So take, for instance, here this this diagram of some city blocks, and we have a starting position right here. We have a coordinate system defined over here with the starting point being right there. So this coordinate system is placed at the starting point. It's just not placed there for sake of clarity. And this particle moves, or this person or car or something like that. Path A kind of comes up over here and to the right. And so it's up 3 blocks and 1 block to the right. And so then we could say the distance of A the distance for A would have been up 3 blocks and to the north 3 blocks, east 1 block. So this would have been a total of 4 blocks. Now we also have path B, which goes all along over here and then up and then back over. It ends up at the same places as car A did, but it clearly went a farther distance. So the distance for B was equal to, we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks. This one a total of 10 blocks. So they have different distances. However, the displacement, their first position vector, in both cases, their position vector R1 was just 0. It started out here, and then their second position was over here. This was R2. Okay. So the displacement of both of these are going to be equal, and so we'd have our displacement vector this delta r, change in position. This is going to be having the origin at 0, 0 right here. This is going to be the coordinates of this displacement vector would be 3 north and 1 east. Oops, sorry about that. This would be 1 east and 3 north. So that's our displacement vector. And the magnitude of this displacement vector, the magnitude here of the displacement, is equal to the square root of 1 squared plus 3 squared. So the square root of 10 blocks, which is shorter than both of the distances because the displacement is just a straight line here. So it's possible that we have a particle starting here and traveling along some path like so, coming back all the way over here. The displacement of that particle over the entire path was equal to 0 because it ends up exactly at the same position. However, the distance is clearly not 0. The distance would have been the length of the path along here. So I guess you could think about this like in your day-to-day life. You wake up in the morning, you go to school, you go to work, whatever, and then you come home. At the end of the day, the displacement is 0. However, the distance is clearly not 0 because you travel some long distance. So displacement is a vector. It is a change in position, and distance is just the length at which something has traveled. Normally, we'll break our displacement up such that we have displacement will be in terms of delta x, which I'll generally just write as delta x, but this is a vector, and we also have a delta y because later on we'll want to break everything into components.